Let's be honest, we've all had that thought as a kid, right? What would happen if you just grabbed a shovel and kept digging, straight down? It sounds so simple, but it turns out to be one of the toughest engineering puzzles humanity has ever tried to solve. So let's find out what really happens when we try to dig a hole to the center of the Earth. To really get a grip on just how hard this is, check this out. On the one hand, we've sent the Voyager 2 spacecraft more than 24 times billion kilometers away. It's literally outside our solar system. And on the other hand, the deepest we've ever managed to dig into our own planet is a measly 12.2 kilometers. That's it. And it took us about 20 years to get that far. The difference is just staggering. So that begs the question, doesn't it? Is it actually harder to go down than it is to go out into the infinite blackness of space? Well, let's dig in and see.
All right, to start our journey down, we've got to begin with the basics. With the methods we're all familiar with. How far can we really get by just digging?
Well, the amount of pure human effort is just mind-boggling. With just people power, like at the big hole in South Africa, we tapped out at about 240 meters. And get this, it took 50,000 workers over 4 decades to do that. So then we bring in the big toys, the heavy machinery. The Bingham Canyon Mine is an incredible 1.2 kilometers deep, so massive you can see it from space. But this kind of open-pit mining has a huge problem. You have to dig this gigantic crater, which is not only bad for the environment, it's just not a practical way to go really deep.
So, yeah, it becomes pretty clear you can't just keep digging a bigger and wider hole forever. If we really want to explore the deep Earth, we have to stop thinking about brute force and start thinking narrower, more focused, and a whole lot smarter.
And that, my friends, brings us to the most epic deep drilling project in human history. It's a story about scientific curiosity, Cold War one-upsmanship, and some absolutely incredible engineering.
Meet the star of our show, the Kola Super Deep Borehole. The Soviets started drilling this thing back in 1970, basically in a race to the center of the Earth. You can see they smashed the world depth record in '79 and hit their absolute limit 10 years later. But then they just stopped. Today, the whole site is abandoned, and the hole is welded shut. But here's the thing, it was a scientific gold mine. They found tiny plankton fossils miles down, and even discovered water where everyone thought it was impossible. So why on earth would they just abandon it? Well, to get that, you first have to understand how they did it. They used a technique called rotary drilling. The idea itself is pretty simple. You just attach a super strong drill bit to the end of a really long pipe, and you spin it. Simple, right? But making that work 12 kilometers underground, well, that is a whole other ballgame.
So here's the breakdown. First, the drill bit at the bottom just grinds away at the rock. But then, how do you clear out all that rubble? This part is brilliant. They pump a special high-pressure fluid called drilling mud down the pipe. It shoots out at the bottom and then flows back up the outside of the pipe, carrying all the little rock chips with it. Finally, to keep the whole thing from just caving in, they install a strong protective pipe as they go. It's an incredibly slow and careful process. But as the team at Kola drilled deeper and deeper, they learned a profound lesson. The Earth isn't just a passive ball of rock waiting to be explored. When you get deep enough, it starts to actively fight back. The first big problem was pressure. I mean, just look at this number. For every single kilometer they drilled down, the pressure ramped up by about 270 times the air pressure we feel right now at sea level. The forces trying to crush that little hole and all their equipment were just immense. And yet, what's crazy is that the engineers were actually managing it. For all that crushing force, they were figuring out ways to keep going. Nope, the thing that ultimately killed the most ambitious digging project in history wasn't the pressure. It was something else entirely, something they didn't see coming. It was the heat, just pure, scorching, and totally unexpected heat. Down at the bottom of that 12-kilometer hole, the temperature was a blistering 180 degrees Celsius. That's 356 degrees Fahrenheit. Here's the kicker. This was nearly double what the scientists had predicted it would be. All their models were wrong, and that one single fact changed everything. Because you see, at 180 degrees and under all that insane pressure, rock starts to act weird. It doesn't exactly melt, but it becomes soft and malleable. It begins to flow, almost like a super dense, hot plastic. And that created a problem that they simply could not solve. So here's why that heat was a total dead end. Every time they needed to pull the drill all the way up for maintenance, which you have to do, that gooey, plastic-like rock would start to ooze back in, closing up the very hole they just spent years digging. And it wasn't just the rock, their equipment was failing. The special metal drill pipes would start to lose their strength in that heat. The drill was literally cooking itself while it was operating. Progress just became impossible.
So, after hearing all that, you're probably thinking, why even bother? If it's this difficult, this expensive, maybe even impossible with the tech we have now, what's the point of all this effort? This slide, this really puts it all into perspective. You see that incredible 12-kilometer record we've been talking about? That amazing feat of engineering? It's barely a third of the way through the Earth's crust, which is just the planet's thin outer skin. The whole journey to the center is over 6,000 kilometers. We have barely, and I mean barely, scratched the surface of our own world.
The motivation is all about the secrets hiding down there. If we could just get through that crust, we could grab the first ever physical samples of the Earth's mantle. That would give us incredible clues about how our planet was formed. And get this, some scientists believe that life itself might have been born from chemical reactions between our ancient oceans and the mantle. The answer to where we all come from could literally be right beneath our feet.
And that really leaves us with a final big thought. We spend so much of our time and energy looking up, searching the stars for answers about the universe and our place in it. And don't get me wrong, that is a noble and vital quest. But maybe, just maybe, some of the most profound secrets of all aren't waiting for us out there. Maybe they're waiting in the other direction, right here, deep inside the planet we call home.